Hello. In this video, we're going to do chi-square test for independence using TI Nspire calculator. Here's our question. We have preferred study method and we have exam performance level. And here you can see there is 120 students and you can see how they are placed. So here we have something called a observed matrix. And then there is three really typical questions you will face if you have a test for independence question. Then at the end of the video, I will have two more questions you might face as well. But let's start with our calculator. So here with your calculator, you will choose the normal calculate mode. So we go there. And then since we have a matrix here, we will have to make a matrix first. I mean, numbers given in a question are in a table, and that's a matrix in our calculator. So you press menu, and then you can see, well, there's a matrix at vector. So we will choose that one, create, and then matrix. And then depending on the question, we will choose how many rows, how many columns. Now we have 3 by 3 matrix and we press OK. And then we just add numbers that are given in a question. And now that you have matrix created this way, now we have an important step here. You have to store this matrix, otherwise we cannot calculate anything. And the way you will store it, you can see here, there's an STO red letters in your calculator above the variation or variables button over here. So you have to press Ctrl and then this var, and then there's an arrow. This means we are going to store this matrix, and then you just choose any letter. So I'm going to choose A, and then we press enter. So now our matrix is ready, and then of course you would check that your numbers are correct. And then we press menu again. We go into statistics, statistical tests, and your calculator or TI Nspire is talking about chi-squared two-way test. So that's the one we choose. So that's the same as test for independence. And now observed matrix, well, we stored that as A. And now here are all the important values we need to answer our question. And here is our question. So first of all, it's saying state the null hypothesis and alternative hypothesis. And that's, of course, we don't need calculator for that. And then there is a determine decrease of freedom and p-value. And then lastly, there is state your conclusion at the 5% of significance level. And in our calculator, here are our values, and you can see, well, we can find p-value, it's given over here, 0.563. df, that's decrease of freedom, that's 4. And later on in the question, I will talk about a little about the chi-squared value. That's also found over here. So now let's look how we answer our question using the values we get from our calculator. So here are our answers from calculator. Well, first of all, the null hypothesis and alternative hypothesis, those are always done the same way in the chi-square test for independence. Null hypothesis is, in this case, that would be preferred study method and the exam performance level are independent. And then alternative hypothesis is that they are not independent. And make sure that you will answer your question clearly, writing down those two quantities we have in our question. And then degrees of freedom is 4. Like I said, we can find that from a calculator. P-value, and round it up with 3 significant figures is here. And then we do our conclusion. And we compare our p-value in the level of significance. And this is true for all hypothesis tests. This is how you do it. So if p-value is greater than level of significance, like in this question, then we don't have enough evidence to reject the null hypothesis. Our conclusion is that preferred study method and exam performance level are independent. Now to the couple more extra questions you might face. But now here, this gives you most of the marks in the chi-square test for independence questions. But then I have a couple more added questions you might face. So let's look at those next. So here are some added questions you might face. First, there is a question about the expected frequency for one given cell in our question. And then there is a given chi-squared critical value, and using that, we could make our conclusion as well. So let's start with the expected frequency value first. And we go back to our calculator. And this expected frequency values you can find with your calculator. And this is how you find it. You press this variable button here. And then you can see, well, there is a statistic expected matrix. So we will choose that. And it will give you the expected values for the previous question you did or previous matrix we did. And here are the values. So here are all those 9 numbers we might have. And now the question was about cell corresponding the group study and high performance. So it is actually the value 15.3. That's actually our answer. And you can find that from your calculator. I will next show how that is calculated by hand. But at least this way you will get quickly answer to the expected frequency number, which you can find from your calculator. And now you can see here. So we were looking for high performance and group study. So what would be the expected frequency for that? And like I said, from our calculator, we can see it's 15.3. So now let's see how that is being calculated by hand, because that would give you a method mark. So you might want to know how that's being calculated, but also finding answer with your calculator is pretty fast. So it's up to you how much time you're gonna use for that question. But now let's see how that is being calculated. So idea is to calculate the expected frequency for high performance and group study is that if we assume that those two are independent, so basically we calculate what is the probability that we, from a group of 120, we randomly choose a student who is high performance and group studying. And we do a multiplication probability calculation. So basically we calculate what's the probability that somebody is high performance and group study. And here's the calculation, how that is being done. And you can see, so probability that somebody is high performing, total number of, group studying, there is total number of 40 who is studying in a group. So 40 over 120, that's probability for studying in a group, multiplied with the probability of high performing, and there is 46 high performing students. So probability is 46 over 120. So that's a probability to find high performant and group studying student. And since we are finding expected frequency, we will multiply that probability with 120. That's the total number of students in the question. Now in a book, you usually find a simplified form. 120 number here is cancelled. So usually the calculation is calculated this way, that total number of students in a group study times total number of high-performing students divided with the total number of students. So that's how you calculate it. That's how you get 15.3. So in a question like this, you would need these calculations for a method mark usually, but at least from your calculator, you will get quickly this 15.3 value. Then there's another question where we are going to use chi-squared critical value to make our conclusion. And from your calculator, you can see you can find this chi-squared critical value here. It's 2.97. And you compare this calculated chi-squared value to given chi-squared critical value, which is in this case 9.49. And you do the comparing, and you see the calculated value is smaller than the critical value. And the way this works, the conclusion how we do it is, since the calculated value is smaller than the given critical value, we don't have enough evidence to reject the null hypothesis, and we come into the same conclusion as we would using p-value. And you can answer questions or you can make the conclusion using either p-value or this chi-squared value. And here is a brief summary for how you make conclusions in chi-square test for independence. So you can use either p-value or this chi-squared value to do the conclusion. And here is how you do it. So if p-value is smaller than level of significance, which is this alpha, we reject the null hypothesis. And you could, with chi-squared values, if the calculated chi-squared value is greater than the critical chi-squared value, we will reject the null hypothesis. Now, I would rely on p-value, since you can do the conclusion using p-value, and using p-value, that's the same with every hypothesis test. So that's why it's safe to learn that it's done always the same way. If p-value is smaller than alpha, we reject the null hypothesis. If it's greater, we don't have enough evidence to reject the null hypothesis. So here is everything you need for chi-square test for independence, and subscribe to the channel if you find this useful, and see you in the next video.